So to get you the feeling what kind of term I can get, I will consider the simplest case. K equals phi C, phi A bar. I will definitely get, so I need 4 thetas. Easiest structure is the following. Get 2 thetas from f theta plus theta minus in phi chiral and 2 theta bars from theta bar, theta minus, bar, bar, bar. It's a team principle. You take bars everywhere. In phi antichiral. So we will get f bar. It is an analog of f squared term in n equal to 1 super quantum mechanics. Okay? Now we need to derivative. How can we get derivatives? Let us take psi plus of t chiral term and say theta bar minus and theta bar plus psi plus t antichiral. Now note that t, so in this way, and take a product. In the product, okay, I'm sorry. This is from phi antichiral. So we already have theta plus bar. How to get theta minus? from the difference in theta minus bar dependence of T chiral and T antichiral. So I may do tedious calculation expanding psi plus of T chiral as sub psi plus of T plus, okay, maybe plus theta minus bar d psi over dt. And I do not need to terms with theta plus and theta minus are omitted. I don't need them because I already have it. So I may combine all terms and get psi plus. I will get this, and I will get a similar term, but not the total derivative. So let me write it. Yes, it is not a total derivative due to fact that psi plus, psi bar plus are anti-commuting. So that's what I'll get. Okay, I'll make it short. So this is the kinetic term for Fermi. I would say similarly for psi minus bars. What about boson? I had x. I have x depending on T chiral and x bar depending on T antichiral. Similarly, I expand to get 4 theta from theta bar dependence of T chiral and T antichiral. But now I get 2 time derivative, and this would be the result. So you may ask why I have only one derivative here. I can get 4 thetas in different ways. I can either get 2 thetas from here and 2 thetas from here, and it will be first derivative of x, first derivative of x bar, or I can take second derivative of x bar and get all thetas from x bar. So please believe me that the overall structure would be like this. After we take into account after we not take into account, after we eliminate total derivatives in T. So we will get the action in component similar to n equals 1 supersymmetric quantum mechanics, with the difference that we have complex structure on the target. Holomorphic coordinates are chiral fields anti-holomorphic coordinates are anti-chiral. Now there is a last thing I want to say.
I have a question.
Yes, please.
What about n equals 1? Couldn't we have gotten couldn't we have introduced chiral and antichiral fields there as well by the same definition?
No, because
Would it be too constricting? And we
yes,
get...
so remark. In n equals 1 theory, we may try to introduce only one constraint. You may try to impose this condition. So I used function f. Okay? then field would start start with fermionic field. So what you may try to write? You may try to write it this way. So actually it's a good question. I don't know how to write it. And then the question is how to write down kinetic term. So in this case, you may write down actions as a single theta derivative of something, and what you will call W chiral field. You know, probably you are right. So actually, I never tried to do this, but it's a good exercise. So probably it is a way. So I never tried to do this, but it is a way to first order formulation of supersymmetric quantum mechanics. I never tried. So it's not that it could not be done. I would say it's a good question. So I would like to conclude with the following, that if we write this term in the action, it's called D term. We will get a theory where bosonic fields start with D2K, D phi I, D phi bar J bar. DTXI, DT XJ bar, plus other terms. And one may check that D2K over D phi I, D phi bar J bar would be the metric on the target space. But it is exactly the condition for metric to be scalar. So I'm coming to where I started from. Really, di gj k bar equals dj gi k bar implies that g is di of something. Of some vk bar. And d I bar g. And similarly, so this is a condition of metric of being scalar. If we also impose di bar gj k bar equals dk bar gj I bar, it would mean that g I k bar is dk bar of something bi. So one and 2 together imply that so I used to write this coordinate x. But it is exactly what we have from the D term. So chiral and anti-chiral superfields and supersymmetric action is intrinsically related to Kähler geometry. And when this was understood, mathematicians were impressed. Tim,
Yes.
is it clear how it happened?
Yes.
So, any questions? Tim, and I will think on your question about chiral fields in n equal to 1.
I think I'll also like do it at home and see what happens.
At least I got your interest in this issue.